Okay, this is section 5.2 on verifying trig identities. So the following 5 steps are some guidelines for verifying trig identities. I'm just going to summarize them. So number 1, you always want to work one side of the equation. So the way our textbook is set up, we want to work on the left-hand side of the equation, and our goal is to get it to look like the right-hand side of the equation. Number 2, anytime you can do some sort of an algebra step like factor, put two fractions together, maybe separate two fractions, square a binomial, anytime you can do any type of algebraic steps, you want to try to do that to make things simpler or to maybe even split things apart. Number 3 says to use the fundamental identities. So far that's reciprocal identities, quotient identities, Pythagorean, cofunction, and even odd identities. So anything that you can substitute using those identities, try to do that. Number 4, if nothing helps, try converting everything to sines and cosines. We talked about that before. If all else fails, just change everything to a sine and a cosine and see how things will cancel out then. And last, try something. Don't just leave it blank and stare at it. Plug something in and see what happens. If your problem gets messier and messier and messier and there's no hope of anything cleaning up, then you've probably done the wrong thing. Sometimes it'll get messier a couple of steps and then things will start to cancel out, and that's what we want to see happen. So try something. Okay, so example 1, we've got sine t times cosecant t equals 1. So there's a couple of different ways that we can do this, and there's not necessarily a right or a wrong way. It's just sometimes some steps will take less steps than others. The goal is to get the left-hand side to equal the right-hand side. So I've got sine t times cosecant t equals 1. So I'm going to replace the cosecant t with something that it's equal to. So I'm going to leave the sine t where it is, and I know that cosecant t is equal to 1 over sine t. And I'm trying to get that to equal 1. So I'm going to bring the right-hand side down with me every time. So I've got sine t times 1 over sine t. So when you multiply times something and then you're dividing by the same thing, those wind up canceling out. So then I'm left with a 1 on the left-hand side, which is what I'm trying to equal, the 1 on the right-hand side. So 1 equals 1. Your work is your answer here, so it's not like we're going to box in the 1 at the end. We know that 1 is the answer. They told us 1 was the answer at the very beginning. You're just showing me the steps that it took to transform the left-hand side of the equation into the right-hand side of the equation. Okay, so number 2 says cosecant or cosine squared beta minus sine squared beta equals 1 minus 2 sine squared beta. So I'm looking from the left to the right, and I'm trying to think ahead about what I need to get rid of because I can kind of see where I'm going on the right-hand side. So on the left-hand side, I see that there's a cosine, but on the right-hand side, I don't need any more cosines. So I want to replace that cosine squared with something that it's equal to. So if you think back to those Pythagorean identities, we've used them quite a bit lately. And the original Pythagorean identity says cosine squared plus sine squared equals 1. So if I rearrange that Pythagorean identity and get cosine squared by itself, then cosine squared is equal to 1 minus sine squared. So I can substitute 1 minus sine squared in for the cosine squared. And then I still have minus sine squared equals 2 or 1 minus 2 sine squared. So I'm looking on the left-hand side of the equation. I have a negative sine squared and another negative sine squared. So anytime you've got two of the same thing, you put them together. So that's going to be 1 minus 2 sine squared beta, which is exactly what I was trying to get to on the right-hand side. 1 minus 2 sine squared beta. So again, the work is your answer. You're showing the steps that it took to get from the left-hand side of the equation to the right-hand side. Okay, number 3, we've got cosecant squared theta over cotangent theta. And I'm trying to get that to equal cosecant theta times secant theta. So eventually I'm going to need to get rid of the fraction because on the right-hand side of the equation there's not any fractions. So what I'm going to do to the top of the fraction is cosine squared can be written as cosine times cosine. I just split those two up. And then I'm still going to put that over cotangent. I could draw a big fraction bar here and put cotangent across both of them, but I'm going to leave it kind of separate. I see in the problem that in the end I need a cosecant theta, and so far I already have one cosecant theta. So I see one thing that already matches up. I'm going to use that to my advantage, and now I'm going to work with the rest of the equation to try to get it equal to that secant that's left. Okay? So I want to see what I can transform the cosecant over cotangent to try to get it equal to the secant. So let's get rid of the fraction. I know I've got a cosecant times a cosecant, and then 1 over cotangent can be written as just tangent. Okay, using the reciprocal identities. So now we're still trying to get cosecant times secant. Okay, so I'm not sure where to go from here. I know I need to keep that first cosecant. So let me see if I can change those next two things to something else that they're equal to and see what happens. So the first cosecant is going to stay. The next cosecant I'm going to change to 1 over sine using the reciprocal identities. And then the tangent I can change to sine over cosine. Trying to get to cosecant times secant. Okay, then I notice I've got 1 over sine times sine over cosine. And again, when you're multiplying and dividing by the same thing, those are going to cancel out. So I've still got the cosecant first, and then I've got 1 over cosine, and I know that 1 over cosine is equal to secant, which is what I was trying to get to, cosecant times secant. Okay, so notice things did get a little messier kind of in the middle, but then when things start to cancel out, then you can see, oh, hey, this is this, so I can replace it with it. Okay, number 4, we've got cosecant x minus sine x is equal to cosine x times cotangent x. So I notice on the left-hand side I'm subtracting two things, but on the right-hand side I'm multiplying two things. So somehow or another we're going to wind up getting rid of that subtraction. So I'm really not sure where to go, so what would happen if I change the cosecant to 1 over sine? If all else fails, put things in terms of sines and cosines. And I'm going to leave the next one minus sine x. I'm going to go ahead and put it over 1 so that I've got two fractions going on here. Now most people would think that these sines cancel, the 1's cancel, we're done. No, they only cancel out when you're dealing with multiplication and division, not with subtraction. Okay, so now I'm going to have two fractions. They have different denominators, so I need the same denominator. Our common denominator is going to be sine x. So it's going to be something over sine x minus something over sine x. Well, the first fraction isn't going to change. It's still going to be 1 over sine x. The second fraction, I multiplied by sine x on the bottom, so I have to multiply by sine x on the top. So the top will be sine x times sine x, which will be sine squared x. And that's going to equal cosine times cotangent. So now the purpose of us doing that was so to put these two fractions together. So the top is going to be 1 minus sine squared over sine x. And we're trying to get that to equal cosine times cotangent. So now look at the top of the fraction, and that looks familiar, Pythagorean identity. We just used it a while ago. 1 minus sine squared is equal to cosine squared over sine x. Okay, so that's good. I've got a cosine, and I know that I need a cosine. So I'm going to split that cosine up on the top. So that's going to be cosine times cosine over sine. So I see I've got the cosine that I need, and then I recognize cosine over sine is cotangent. So cosine times cotangent, which is what I was looking for. Okay? All right, number 5 looks a little more complicated because we're starting with fractions. So I know I've got to add these two things together, and they're supposed to equal 1 in the end. Okay, so I have two fractions with different denominators. So just like when you learned how to add 1/2 and 1/3, the common denominator was 6. And the reason it was 6 is because you multiplied 2 times 3. Same thing here. Our common denominator is going to be the two denominators multiplied together. So that common denominator is going to be sin x plus 1 times cosecant x plus 1. So both of our denominators have to have sin x plus 1 times cosecant x plus 1. So the first fraction did not have the cosecant x plus 1, so that's what I have to multiply by on the top. And the second fraction did not have a sin x plus 1, so I had to multiply by sin x plus 1 on the top. So now I can smush my two fractions together. I'm going to add the tops. The top is just going to be cosecant x plus sin x plus 2. 1 plus 1 is 2. Now the bottom, I'm going to go ahead and FOIL it out, and we only need one bottom, so I only need to FOIL it one time. So sine times cosecant is just sine cosecant. Outside, sine times 1 is sine. Inside, 1 times cosecant is cosecant. And last, 1 times 1 is 1. Okay, we're still trying to get this to equal 1. So I'm going to leave everything the same, but notice on the bottom I've got two things being multiplied together. Everything else is addition. So I'm going to keep everything the same, except for that first cosecant on the bottom. I'm going to change it to 1 over sine. The reason I'm going to change it to 1 over sine is I know that sine times 1 over sine will cancel, and I'm just left with that 1 on top. Okay, so the top of my fraction is cosecant x plus sin x plus 2. The bottom of my fraction, I'm going to rearrange. Cosecant x plus sin x, and then the 1 at the front and the 1 at the back add to equal 2. So that's beneficial to me because now everything on the top is exactly the same as everything on the bottom. And that's how I can cancel the 2 out. And it's like saying 5 divided by 5, 17 divided by 17. It's going to equal 1, which is what I was looking for. Okay, number 6, I've got tangent of pi over 2 minus x times tangent x equals 1. So this first identity, tangent of pi over 2 minus x, is one of the cofunction identities, and it equals cotangent x times the tangent x that was there, and I'm trying to get it to equal 1. Well, I know that cotangent is equal to 1 over tangent times tangent is equal to 1. So when you're multiplying and dividing by the same thing, they're going to cancel out. So 1 equals 1. Some of these are going to work out really fast, just a couple of steps. Some may take a few more steps. You never know what you're going to get. Okay, last one, tangent x plus cotangent y divided by tangent x times cotangent y. And I'm trying to get that to equal tangent y plus cotangent x. So notice there's two different variables and two different angles in this problem. There's x and y. Okay, so first thing I'm going to do is I'm actually going to split this fraction into two fractions. It's like uncombining like terms. So the first fraction is going to become tangent x over tangent x cotangent y. Plus, the second fraction will be cotangent y over tangent x cotangent y. Okay, so I notice in the first fraction there's a tangent x divided by tangent x. So those are going to cancel, and I'm left with 1 over cotangent y. The second fraction, I notice that cotangent y divided by cotangent y is going to cancel. So I'm left with 1 over tangent x. Okay, I know that 1 over cotangent is equal to tangent. So 1 over cotangent y is equal to tangent y. And 1 over tangent x is going to equal cotangent x, which is what I was looking for. Tangent y plus cotangent x. Okay, so your homework is on page 387, 2 through 30 evens. This is due on Monday morning.